Good morning. Welcome to AP Computer Science A, and A is for amazing. Today we are going to be covering section 2.8. And I know what you are thinking, Diaz, what happened to 2.7? 2.7 deals with, and you should have your notes with you, wrapper classes. Now, wrapper classes are easy to understand, but the problem that we have is that we're actually not going to actually use them. We're not going to use them until semester 2, whenever we cover array list. In array list, we will have a need for them, but for now, we don't really have a need. And adhesive and the College Board feels like you should be introduced to wrapper classes. So I'm just going to give you a quick rundown. Wrapper classes are used to be able to convert primitive types, ints, into class data types, objects, such as an integer. So the difference is that whenever we go into array lists are not going to allow us to be able to hold any primitive types. So in order to be able to hold integers or doubles or booleans, we need to be able to use the wrapper classes. So we're going to wrap up the 9, and now it's going to become a class data type of an integer. And that's basically it. And we can do the same calculations as if they were integers. We can use them. We can actually do the same thing as if they were ints. And they provide all the information for you so you can go through. We can do a compare to, but we really don't have a need for it because we can actually compare two numbers on the next unit. We can compare two integers, but we'll do that on unit 3. We've covered integer minimum value and integer maximum value, correct? All of you guys remember that integer minimum value is negative 2 to the power of 31. And all of you guys remember that integer dot maximum value is equal to 2 to the power of 31 minus 1. And those are uppercase because they're constants that do not change. That is the lowest value of an integer. That is the highest value of an integer. And we also said that they are final because you cannot change them. We also have a double class, a double wrapper class. So we can take a double, which is a primitive type, and wrap it up, so it becomes a double. Just like in Halloween, you wrap yourself up and you become a different person, correct? Or a different character. It's basically the same thing. Now, there are different ways to be able to what we call wrap them and unwrap them, but Java actually does it for us. So we really don't have a need for this, and we'll talk about this during the second semester. So notice that this is the constructor that we can use. Java automatically does it for us, so we don't need to. We have the minimum value, maximum value that we use on the last unit. And then this is to be able to unwrap it, but Java will automatically do it for us. So a lot of these concepts that we have, yeah, they used to be a little more useful, those two methods, the constructor and the method, but not Java automatically does everything for us. So I know some of this stuff doesn't make any sense now, but once we go into second semester, it will. So we have a double wrapper class, and we also have what we call auto boxing, unboxing, automatically boxing auto, and then automatically unboxing it. But we'll go over that second semester. So therefore, today we are going to be covering section 2.8. So therefore, this is correct. So just make sure that you guys have your notes. Make sure you type in your name and click submit. On 2.8, we're going to go over the math class, math functions. And all of you guys should have this on page 3 of your packet. This is the Java quick reference that you guys will be able to use during your AP exam. And if we look at this, let's see, we have used the string, we constructed, you've done the constructor, right? And we've done it two different ways. The way that we did it on unit 1, where we just did string name equal David Diaz. Or the second way that we actually know that's the more proper way of doing it is calling the constructor by using the word new. We've also done the length. We've done the two method substrings. And what do we call whenever there are two methods with the same name, but they have different signature? It's called overloading. So therefore, the substring method is overloaded. We've also used the index of to be able to find the location of a specified string or a desired string. So if you want to be able to find out where in the string is the word day, then we can use index of. It's going to return an integer because that is going to be the index of the word or the first time that it's there. So if there's two words or three words or the word day appears three times, it's always going to give you the first one. Then we haven't used equal because we're going to use equal once we're going to if statements that will make a little more sense. We then compare to. Compare to is going to return an integer once again, whether negative, 0, or positive. And you can refer back to your notes. We've used the integer class, we've used the minimum value, maximum value, and we went over this there briefly. But we'll come back to that in second semester. Same thing with double class. We're going to come back to this second semester. So what's next? Math class. And for the math class, we are going to have the following methods that you will be responsible for. You can use this on the test. So we have the absolute value. Once again, we have two absolute values. So therefore, those two methods are overloaded. We have the power, right, the base and the exponent. So it's going to take two doubles and it's going to return a double. So something that you need to be able to keep in mind is be able to read this notation. For example, in this case, absolute value, you can take it as a parameter an integer, but it's going to give you back an integer. Absolute value can take in a parameter of a double, but it's going to give you back a double. Power will always take two doubles, and it's always going to return a double. So the base and the exponent with a comma in between. SQRT is the square root. It's always going to take a double as a parameter, and it's always going to return a double. And the last and most important one for this class is going to be random. We need to make sure that you understand how to use random. That's always, notice that there are no parameters that's going to take in, but there is going to return us a double. So let's get started. So we should have a Replit in the way. So let's move myself out of the way. So we have, make sure that you type in your name. Make sure that once you finish, you click submit. And we already have the scanner class imported. So let's go start with using the scanner class. That way it will allow us to be able to talk about a few more things. We have scanner scan equal new. What does the word new do? The new is going to instantiate the variable. So basically it's going to please make space for in memory for the data for the variable. So therefore this will be scanner system dot. So several things to be able to keep in mind is that in this case, in order to be able to use the scanner class, we have to use the word new. Whenever you use the word new, that means that we are going to create an object. We're going to create an instance of the class. So the same way that we create rubber duckies, right? Well, once we have a blueprint, we can actually create a rubber ducky, and then another one, and then another one. And because we have the blueprint, we can actually create as many as we want. But then we need to be able to have a handle. In order to create it, we need to be able to just use the word new, which calls a constructor. Then inside the parentheses, we are going to give some information. Now we know that if we don't give any information, for example, if I say, I need a rubber duck, what color do you think the rubber duck is going to come back? It's going to come back yellow. But if I want a different color, if I want a white one, then I'm going to specify, most likely there will be a constructor that will allow me to type in the color here. Or if I want a blue one, or if I want a pink one, or if I want a purple one, or if I want a brown one, you get the point, right? So therefore, this needs, in order to use the scanner class, we need to use the keyword new. By using the keyword new, we know that this class, the scanner class, is non-static. So that is the first time that we talk about non-static. Notice that the method is static. In this case, so I should just say in order to be able to utilize, we're going to talk about two things. We're going to talk about a class that's static, and sometimes there are going to be only methods that are static. In this case, because we have to use the word new, that means that the scanner class is non-static. If your method or your class is static, that means that we do not need to use the keyword new. That means that we do not need to be able to create objects in order to be able to use the class or the method. The math class is a static or non-static. The math class is a static class, which means that we don't need to be able to create any objects. That means that we need to be able to we are able to just use it. We'll come back to that in a second. So for now, so the scanner class is a non-static class, which means that we need to be able to construct an object named scan. We have, let's go and get a double. So it'll be double. And let's go and label it num1. And the next double. But did I forget something? What did I forget? So whenever you have a non-static class, means that you have to create an object. Therefore, we need to be able to have a handle for the method. We cannot just use the next double without a handle. That means that next method, or the next double method is also a non-static. That means that the next double method is inside the scanner class, and they both are non-static because in order to use the scanner class, I need to be able to create an object of the class or an instance of the class. And in order to be able to use the method next double, I also need to be able to have a little handle that will refer to the object that I created. The same way that we use the, let's see, is the string class. Is that static or non-static? What do you think? The string class is a non-static class because non-static means that we have to construct an object in order to be able to use it. So we always use word.length, word.substring, word.index of, word.equals, word.compared to. In the same case, scan the next double. Now, I can actually use the math class is a static class, which means that we do not need to be able to make an object. We can just use it. So we can use it to be able to, let's use the first one. Let's see, what is the first? The first one is So therefore, in order to be able to use the math class, we don't need to have a handle. So I can just, if I want to be able to print the absolute value, let's talk about absolute value. I know that that one is 2 of them, so that means that's going to be overloaded. So because that's a double, if I do system.out.print ln, and I just print the number 1, but I want the absolute value. So the way I do this is going to be math, that is the name of the class, that the method, we're using this one here, so it'll be absolute value. And then inside will be a number, which will be num1. So let's go and run it and see what happens. Oh, error. Main Java error reach in a file while parsing on line 25. Do I have one? Oh, I don't have it next to it. So notice that in this case, I missed, somehow I deleted. And also, let's go and send a message. Please enter a double, right? That'll be nice to be able to find out. And let's say, please enter a double. Now let's go and run it and see if there are any other errors. And let's go and type in a negative 5.3. Then what is it going to print? It's going to print 5.3. Absolute value will just give us the absolute value. Isn't that impressive? But one of the things that you have to remember is that you are using this method here, not the first one, but the second one. And notice that I don't need to type in a handle. The handle is actually basically just the class itself. So math class is a static class because I do not need to print, or I do not need to be able to create an object. I can just use any of them as long as I send in the correct argument, which is received as a parameter. We can also just say system.out.print ln and say math absolute value and just give it a number, negative 1.3. Notice that I place the extra parentheses just because it's a little easier to read, but you don't have to. But it does make it a little bit easier to read your code. Now, I did not need to create anything about the 1.3. I basically just using the class. So therefore, the math class is a static class. Let me just type that here. Math class is a static class. Why? Because we do not need to create an object. We can just use it. We do not need to create different objects in order to be able to use it. Don't do that to me, please. Excellent. So therefore, what we can also use the absolute value, and we can just send an integer. Enter double. Negative 9.7. No. Negative 9.7. 9.7. So therefore, in this process, we are using this class, this method here, which takes in a double and returns a double. In this case, we are using the first one, which takes in a integer and returns an integer. Now, how else can we use the absolute value? So think about different type of problems that we can use an absolute value. Give you guys time, type that up. So in this case, another way to use the absolute value, and now let's go and say enter 2 doubles. Let's go and type in 2 doubles. So therefore num1 and let's say double num2 equal to scan dot next double. And one way to be able to, or one good use in our class to be able to use the absolute value is to find the distance between two values. So therefore, let's go and say double num distance is equal to num1 minus num2. Now, if I do this and I just go and print the distance, and I'm going to run it. So, expected. Where did I forget my line number 18? Where did that come from? Interesting. Two doubles. So the first one is 7.1. The next one is 3.5. That works fine, right? Now we are going to have that issue whenever we are subtracting two doubles. So we know that 7.1 minus 3.5 should be 3.6. But we'll deal with that later. That'll be another lesson for another day. But what if I type in it backwards? So the distance or the difference between both of them will be 3.6 if we round it up. But what if I say 3.5 and 7.1? We know from math class and from science that distance is measured in positive values. So therefore, one of the things that we want to do, we want to be able to take the absolute value, and the way we do this, because it's in static class, we don't need to create an instance or an object. We can just go ahead and use it. And that is a good use for this class and in the future to be able to find the distance between two values. Or if you enter a negative number, negative 3.76 and negative 1.6, 2.0. So we want the distance is always going to be positive. So that's going to be a good use. Now, if I want to be able to take in an integer, so let's say I want to enter two integers. So I want to change this to int. And therefore, I'm looking for an integer. So therefore, I'm going to declare and get two integers from the user. And therefore, our result should be an int. And I'm going to run it. Now I'm going to type in two integers. So therefore, it'll be 3 first, 9. And gives us a positive value. So notice that I did not change anything here because now those are integers. So now instead of using this one here, I'm using the first one because they're overloaded and absolute value can take in an integer or a double and it'll correspond to whatever you've given. So if you enter an int, you'll return it. So if I go back and type in two doubles, but then whenever I want to be able to get my answer as an integer, if I want to be able to get a whole number, it's going to give me an error. Incompatible types, possible loss of conversion. So what should I do? So let's say I want to be able to type in 3.5, 7.1, and I just want to be able to get the whole number itself. Then I can just go in and cast it, correct? So now I can say 3.5, 7.1, and I'll get just that whole number itself. So we can actually just cast it into an integer. But if this is a double, this is using this method here, which is going to give you back a double, and therefore this will not be proper. It'll give you a syntax error because now this is returning a double and going to save it into an integer. So in that case, you need to cast it as an integer if that's what you want. Otherwise, we need to be able to ask for an integer, or save as a double. Or otherwise, we need to be able to save as a double if that's what you want. So it all depends on what you are looking for. So that is the absolute value methods. the power is going to take two doubles and it's going to return a double. So I entered two doubles, and now we're going to use the power, and we're just going to use, and let's just say exponent. And we're going to print the exponent. If I can spell it correctly, that might be helpful. So the exponent, which is POW for power, is always going to be the base first, which is num1, comma, num2. So the first one will be your base, and the second one will be your exponent. Let's go and run it. And enter two doubles will be 2.0 to the power of 3.0. Will give us 2 to the power of 3. So in this case, you can take an integer, and also going to you can take two doubles, and it's going to return a double. But now let's say that we're actually going to get two integers. Now I'm going to type in int. Let me change this to integer. And therefore, I'm just going to run it and see what happens. Int. I knew it was in int. I thought twice about it. Did you notice? Let's try again. There you go. Enter two integers. So now I'm going to say 2 to the power of 3 will give you 8. So you'll say, hold on, aren't you supposed to type in two doubles? But right here, that's a integer and that's an integer. Remember that integers are small, so they can count as they'll fit into a double. So even though this is an integer, it's able to fit into the size of a double, so that's fine. But it's always going to return. So in case sometimes you say, well, I'm typing in 2, typing in 3, they're both integers, and then you're going to be expecting 8 as an integer, and that's when you're going to end up with an error. So one of the things that you have to remember, just the fact that absolute value is overloaded, power is not overloaded. So therefore, if you want to have it as an 8.0, you need to place a double here. But if you just want 8 as your answer, we need to cast it. 2, 3, 8. But absolute value is overloaded. So if you type in an integer, it will give you an integer. If you type in a double, it will give you back a double. You will return a double. Power is now overloaded, so therefore you cannot get back. And the same thing with square root. The square root, let's just go and type in one integer. Or just say an integer. Therefore, we just need this one here. And now we're going to say square root. I'm going to delete this. Its math is a static class, which means that we don't need to make a instance of the class. And in this case, square root is just going to take a number 1. And let's go and type in square root. We're going to run it. We are taking in an integer. Run it. We are taking an integer, so this is square root of error. Possible level of conversion correct is, even though we are going to expecting to type in a 9, we are storing it in an integer. So we have two choices. What's our first choice? Our first option is to change this to a double, and then that should work fine. Do you agree? So let's say the square root of 9 should be 3, like this is 3.0. If we're actually looking for 3, then we can keep it as an integer. But if I do type in integer, what should I do to fix it? Because otherwise I'll get an error. Correct. I should cast it. And that way I do get my 3 that I need. But if you do want it as a double, because you might type in the square root of 2, which all of you guys know the square root of 2 is 1.4. 1.4. And in math analysis, you also remember that the square root of 3 is 1.7. And that goes back to sine and cosine. Now you're saying, hold on, this that's taking in a double, but now you're typing in an integer. So this can count as both. So if you want to be able to say just double, same thing with the before, then that will give you the same. So if you do need to be able to take the square root of a double, then we just need to make a few modifications. Type in a double, and now the argument is going to be a double, and it should work. 1.7, and we can take the square root of 1.7. Questions? So let's go into the last one, random. Random is very important in our class. You're going to be able to, throughout the class, you're going to have to calculate random numbers. And we're going to say rand. We're going to call the variable now. So let's go and enter, let's just go and calculate. For now, we're going to get rid of all this. We can type it up in a few minutes. So first, let's get rid of the entire thing. So the method that we actually are a little more concerned about is random, that we're going to be using throughout the class, first and second semester, and it's going to be also in your AP exam. So we know that the math class is a non-static class, so therefore I can create a random number, and we know that's going to return a double, so we can say a double. And let's go label it R for random 1, or R1 is equal to, we don't need to create a object in order to use it, so therefore I can just say math, the name of the class, and random. That is going to give you a number from 0 to 1, a double, so it's going to be a decimal, not including the number 1, so it's never going to be 1. There's a very small probability that it might be 0, but, and let's go and print it out. System.out.println and R1. And then we can just run it. Sometimes you might want to print more than 1. So if you do need to be able to print more than 1, let's go and say, let's go and print another random number. And let's go and say, let's go and run it. Same number. Correct. So you need to be able to recreate it. So if you want to be able to name it the same R1, if you're not going to use it again, you can say random, and that's going to create another different random number. If you do need to save it and use it for later, then we can just say double R2 and then print it out. If we need 3 random numbers between 0 and 1, then we can just say random 3. If you don't need to save it, then you can just continue with random 1. If you there. So there are 3 random numbers between 0 and 1. Now, most of the time, we actually want to be able to get a number between 1 and 10, including the 1 and the 10. So therefore, we actually want to be able to get integers. So what we're going to do is the following. So let's go and give it the last 2. And this is the process. It's also in your notes. So random 1. We know that the math randoms is going to give us a number from 0 to 1, not including 1. So let's say that we want 10 numbers. So we want the numbers from 1 to 10. So therefore, we are going to multiply by how many numbers we want. In this case, will be 10. Is it 10 or 11? So just be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we do. We need 10 numbers. And now, if I run it, it's going to give me the number from 0 to 9, correct? Because if the number happened to be 0.1, and you multiply by, or 0.1, and if you multiply by 10, it's going to give you 0.1, correct? And if the number was 0. Or it was 9, the biggest number that it can be was 999, then that'll give you 9.9. If the number that you got was 0.001, which can be, and then you multiply by 10, then the new number will be, we just move the decimal to the right twice, or so once, so it'll be 0.01, correct? So therefore, this is going to give you a number from 0 to 9.9999. So what we're going to do, I want it to go from 1 to 10. So I'm going to add 1. And most of the time, we're going to be adding 1 to be able to shift them over. And now, once we add 1, it's going to give you 10.9. And once I add 1, it's going to give you 1.11. So now it's going to give you the numbers from 1 all the way to 10. And I want to be able to chop the decimal off. So what I'm going to do, because I do want to be able to get an integer, now I double. I want a number from 1 to 10. I am going to cast it. So therefore, I'm going to place this in parentheses. Now, adhesive does it slightly different. I find this method to be much easier because you don't have to worry about where the parentheses are located. And I'm just going to use, I'm going to cast it as an integer. And now if I print it, it's going to give me a number from 1 to 9. Now, if I want another number, let's say we want to be able to have another number, then I need to be able to just repeat this, same thing that we did before. But I'm not going to declare it, and I'm just going to print it out. That should give me 2 numbers between 1 and 10. And if I want to be able to do 1,000, then I can do that. But once we go into Forbes, we can actually print a few more, and I can just. So all the numbers that we are going to be printing, all the numbers that we're going to be printing are the random numbers between 1 and 10. So therefore, you should not be able to see any zeros or any 11s. So that is the formula to be able to print random numbers. But let's go and say let's go and do a few more, and then we'll be done for today. So let's say I want to print a random number between 5 and 12. And we're usually going to say inclusively. So we inclusive. That means that we do want the 5 and we do want the 12. So therefore, how many numbers, this location is going to be how many numbers do we need? Let's see, 5, 6, 7, 8, 9, 10, 11, 12. So 8 numbers. And the way that you calculate that is that you basically just take the 12 minus the 5. That gives you 7. But we are counting the 5, so therefore you always have to add 1 more. And now that is this number here, which is 8. this number here is going to be how much do you need to shift it? Because right now it'll be from 0 to 7 if we don't include the 1. And we need it to be 5, so therefore we're going to be, this will be the first number that you want, which is 5. And now if I run it, that'll give me a number from 5 to 12. And if I copy and paste it, I'm just going to copy and paste it so you can get different numbers. I just don't want to make sure that I don't declare it again. And that makes it all faster. We don't have to change the number, the variable name. Make sure that's always inside your main method. So therefore, all the numbers that we get are going to be from 5 to 12. There should not be any 4s and no 13s. So therefore, that is the formula that we are going to use. So try this yourselves. Let's go and see if you can come up with the numbers, a random number from 15 to 35. What are you going to place here and here? Pause it, see what you get. Got it? Correct. So therefore, it'll be 35 minus 15 will give you 20. Because you are counting 15, therefore, this will be 21. That number will be 21. And one number should be this. This is the first number that you want because we're basically going to shift it. Right now, if we don't include the 5, it's going to give you 21 numbers, but it will be from 0 to 20. So therefore, we're going to increase it by 5 because that's the first number that we, by 15 because that's the first number that we are looking for. And sometimes to test it, because we haven't gone over loops, we can just copy and paste. Make sure that I get rid of this. And then I can just copy and paste it. And then run it. And just confirm that all my numbers are between 15 and 25. So on 35, so therefore there should not be any 14s. And there should not be any 36s. And that will conclude the lesson for today. Make sure that you guys pay attention to this setup. I kind of explained a little bit more on how the numbers come about. And don't forget to write down those 3 exercises that I have here for you. Have a great day, and I'll talk to you guys next time.